Okay, this is section 8.3, the second last section in your Math Links 9 textbook on algebra solving linear equations. We say solving linear equations because it relates to when we graph the points on a graph, and we don't correlate the two things yet, but you will eventually correlate the idea of variables and unknown values to being able to also plot their values on a Cartesian plane when you have two variables x and y. Okay, with that said, we have Cal and Tiana solve the equation three groups of x minus 4.3 equals negative 2.7 in two different ways. Cal used distributive property first, while Tiana divided first. Show both of their methods. So I'm going to first show you if we took this equation and we solved it with distributive property, what we would have to do is multiply both groups by 3 because we don't have one group of x. We actually have three groups of k minus 4.3. So when we put those red arrows in, what we are actually doing is called expanding using distributive property. So we have not one group of this, but we have three groups of k minus 4.3, which means we have three k's and we have three groups of negative 4.3. So if I take my calculator and say, okay, one group of 4.3, if I multiply it by 3, then three groups of that, three groups, come on, there we go. Three groups of it are negative 12.9. So it's important to realize that that and that are the exact same expression. One is just using distributive property, one is expanded already. Okay, so once we have that, Cal would have then had negative 2.7. And of course, from this point forward, we're just going to add 12.9 to get rid of the constant. To get 3k equals 10.2, and then we're going to divide both sides by 3 to get k equals 3.4. So by using distributive property, it keeps it pretty straightforward, especially when we're dealing with decimals. When would this probably not be as easy? Instead of having decimals as our constants and our coefficients, if we had fractions, this might not be the easiest way to go. But Tiana decided to divide first. So she took the same equation and she decided to do what? Gave it to both sides. Divide both sides by 3. And the reason why she did that, she said if three groups of k minus 4.3 is negative 2.7, then one group of this is going to be equal to negative 0.9. Now we could see based on the amount of work here that that was a really efficient way to work out isolating, because now we have a one-step equation and all we have to do is add 4.3 to both sides and we will have k isolated to become, what did we say it was? 3.4, positive 3.4. Which way do you prefer? Probably the second, because it requires the least amount of work. But the most important thing about the second method is understanding the reason why we divide both by 3 is because we have three groups of k minus 4.3, and if I divide both sides by 3, keeping in mind this idea of balance of equality, I have one group of k minus 4.3 equals a value. So that's a very efficient way to do it. We'll skip the section. We'll do this one. So it says Renee and Paul used different methods to solve this equation. Renee first multiplied both sides by a common multiple, or 10, and Paul rewrote it to express it as half of x plus 1 equals 3/5, and then divided both sides by thing. Which method do you prefer? Whose method do you prefer? Jack, who do you prefer? Exactly. Renee's method is definitely the best, because we learned from section 8.2, when you multiply any fraction, and I'm just going to take 3/5. If you multiply 3/5 by 5 or 10 or 15 or any multiple of the denominator, what type of answer do we get? A whole number, right? The same thing is true when you take an algebraic fraction and multiply it by 2 or 4 or 6, etc. When you do that, you're going to end up with an answer that is not a fraction, okay? So by multiplying both sides by 10, this is not going to become a fraction anymore, and this is not going to become a fraction. So when we think about it, if we cross reduce 5 over 1, I'm going to have 5 groups of this amount up here, which is 5x plus 5. And when I multiply this by, if I cross reduce, I'm going to have what is my equivalent value? If I cross reduce, what's this going to become? Anybody? Everybody's sleeping. It's 6, right? So once I do that, I got a simple equation. Subtract 5 from both sides. 5x equals 1. Divide by 5. And your final answer is x equals 1/5. Or if you want to change it to a decimal, 2/10. Question 4 says Victor and Ashni, I guess, we're solving the following problem together. A square with a side length of x plus 1 has a perimeter of 18.6 units. What is the value of x? So they said, if I was to write all the x plus 1s in, and I'm just assuming this is what they thought, the perimeter of this particular step could be construed as x plus 1 plus x plus 1 plus x plus 1 plus x plus 1. And that would be a very rudimentary or basic way of solving the perimeter, those 4 sides added together. If you made the connection to the fact that I can take this, and there's really 4 of those, I can then say, well, 4 multiplied by x plus 1 is the same thing as repeated addition, because repeated addition and multiplication are the same freaking thing. So with that said, if this represents the perimeter, and this represents the perimeter, and the perimeter is really given to us as 18.6 units, so I can swap out that p for 18.6, and I have now created an algebraic equation which I can solve to determine the side length of that particular square. Divide both sides by 4, and one group of x plus 1 is going to be equal to, I have no idea, brain's not working, 18.6 divided by 4, 4.65. Have I lost anyone so far? All I did was I divided both sides by 4, and I swapped my sides. I shouldn't have, but anyway. X plus 1 is equal to 4.65. Subtract 1, and x will be equal to 3.65. Okay. Once we know that, what do we have to do? We're not done yet, are we? Because the question is, how do I know what side length it is? Well, if the side length is x plus 1, and x's value is 3.65, we already solved it right up here, didn't we? X plus 1 equals 4.65, so therefore, each of those sides is actually a value of 4.65. Question 5 says, write an equation represented by each of the following. So if I think about what this means, this is a paper clip, which we're going to represent its value by x and 5 cents, or plus 5 cents. How many paper clips plus 5 cents do we have? We have 3 of them. So we can take that amount and we can multiply it by 3, and that represents all of this right here. 3 groups of a paper clip plus a nickel. And that has an equivalent value to 60 cents, which we're going to represent with that. Now, do we need that extra 0 on that 60 cents? Not really. Since we're dealing with money, usually we do, but you don't have to have it if you don't want to, because that's still 6/10 of a dollar. Isolate by dividing both sides by 3, so instead of having 3 groups, you have 1 group is equal to 20 cents. Subtract a nickel from both sides. And the value of x, or the value of a paper clip, is 15 cents. Question 6, we have a whole bunch of questions. I'm just going to do the most difficult one. I'm just going to do D. And you could do it one of 2 ways. Now, obviously, we could expand using distributive property. Multiply negative 3.6. You know what? Yeah, how many of you did distributive property on that question? A few of you. Well, then let's do it. Let's just say to heck with it. Let's try it 2 ways. Let's try, what is 3.6 multiplied by 0.25? Or another way to think about it is, what is 25% of $3.60? Well, 50% is $1.80. So half of $1.80 would be 25%, which would be 90 cents. It should be negative. Yeah, there it is. Look at that. Negative 0.9. And I know that because a negative times a positive is a negative. And then negative 3.6 times negative r is a positive 3.6r, equals 0.1 cents. So a negative 90 cents plus $3.60 multiplied by however many paper clips I have. I'm thinking about that picture again, equals 90 cents. Very difficult. Add 90 cents to both sides. And I get 3.6 R is equal to $1.08. Right? Divide both sides by your coefficient, and you will get whatever $1.08. How many $3? That's not going to work. $1.08 divided by 3.6 equals 0.3, 0.3, 0.3. So R will equal 0.3. Is that positive or negative? I think it's still positive, isn't it? Yeah. Okay. Now, if you took that same question, and even though I shouldn't do this, I'm going to, negative 3.6 multiplied by 0.25 minus R equals 0.18. What's an easier way for me to solve that, Donovan? Instead of expanding using distributive property, I could do what to both sides? Alternatively, I could have said, listen, I don't want to know what negative 3.6 groups of them are. I want to know what one group is. So I got one group of this is equal to whatever 18 cents divided into piles of $3.60 is. So 18 cents divided into piles of $3.60, I could make 5% of a pile or negative 5% of a pile. And I'd subtract my constant from both sides. I get negative R is equal to negative 0.3. Divide both sides by negative 1, and R will equal a positive 0.3, which is the same answer I got over here. Let's skip 7. Let's go on to 8. Let's do 8. What did I make you do, A and D? We did all of them. Okay. So with the first one, how much of n plus 1 do you have here? You just have half an amount. So if n plus 1 was a thing, a value, a number, this expression represents half of that value. And half of that value is equivalent to negative 3/4. So when I think of it in terms of not n plus 1 over 2, but rather half of the value of n plus 2, I realize that if I double this amount, I will have an entire value of n plus 1. But again, doubling this side requires me to double this side. So I simply multiply it by 2. Multiplying a fraction by a whole number, it's sometimes easiest to do that way. In which case you get negative 6 over 4. Or if you were smart and intelligent and you cross-reduced, what's negative 6 over 4 in lowest terms? It would be negative 3 over 2. And negative 3 over 2, I could write that as negative 3 over 2. But since I have a whole number that I'm going to subtract from both sides, what's a better way to write negative 3 over 2? Negative 1.5. And I'm going to change it to that because I know my next step is to subtract a whole number. So negative 1.5, take away one more. Is it negative 1/2 or negative 2.5? If I owe $1.50 and I have to take away $1 more, negative 2.5. And that's your final answer. All right, we're going to go back to 7D right now. So here we have an equation of negative 9.5 groups of x minus 4.2. Now, obviously, if I took away this negative sign, this makes more sense. I have 9.5 groups of x minus 4.2. When I put that negative sign in, it changes the meaning of it, but it doesn't change the procedure of getting the answer. So, Elizabeth, which method did you use? Did you divide both sides by negative 9.5, or did you expand using you expanded? Okay. So we're going to expand using distributive property. Negative 9.5 times x is negative 9.5x. Negative times a negative. I know my next term is going to be positive just because of my sign rules. And 9.5 times 4.2 is 39.9. And that's going to equal 7.5. So now we have this equation that is much more manageable. I'm going to remove 39.9 from both sides. And if I have 7.5 and I remove 39.9, or if I have $7.50 and I owe $39.90, if I use my calculator, 7.5 take away 39.9 is going to be negative 32.4. And over here, I'm going to have negative 9.5x. So far, so good? Okay. Now that we have that, I'm going to get rid of my coefficient by dividing both sides by negative 9.5. And when I use my calculator, I know that I've isolated x. By doing that procedure, I've isolated x. I take my calculator. I go, what is 32.4? I don't need to worry about my signs because I know my answer is positive. Divided by 9.5. And my answer becomes this long string decimal. So because we have this, there should be a repeating pattern at some point. Is there? 10563, 42, 10563, 63, 163, 157. There is something in there, but who cares? We're going to put approximately equal to 3.4. We're just going to round to 1/10 of a decimal. If you needed to be accurate, you would have to find what pattern is repeating, because there is a repeating pattern, and write it as a repeating decimal. But we're just going to put approximately equal to 3.4. All right, so we did A and 8. We're going to go back and do D right now. So we have 7 over 6 is equal to 2 groups of 5 minus G divided by 3. We have a lot going on in this question. So the first thing I'm going to realize is that if I think about how much of this do I have all of it? No. It's important that you realize you have a third of that, right? You don't have all of that highlighted yellow value, you just have a third of it. And knowing that you have a third of it, this next step of multiplying by 3 means, very importantly, that you have a full group of that, right? Acknowledging you have a third of it, and by multiplying by 3, I know you could probably say 2/3. You could also do that. So I'm just going to start with that, and then we'll do the other one after. So acknowledging that that's true, this would be then true by multiplying it by 3. And multiplying this by 3 would give you, cross reduce, would give you 7 over 2, or 3.5. You guys okay with that so far? 21 over 6, 3.5. 7 over 2, still 3.5. Regardless of what you did, when you take 7, 6 and multiply it by 3, you would end up with a decimal of 3.5. Okay. Once you have that, you could divide both sides by 2, and you get 1.25, or sorry, 1.75, or 1 3/4 if we keep it as I should have actually kept it as a fraction, shouldn't I? Whatever. Too late now. 1 3/4 equals 5 minus G. Subtract 5 from both sides. A lot of people struggle with this, right? 1 3/4 take away 5, right? So if you can't do it from a fraction perspective, let's just think of it as a decimal. 1.75 subtract 5. Well, 1.75 subtract 1.75 is 0. And you still have to subtract 3.25, right? Which means it's negative 3.25. Or if you want to think of fractions, negative 3.25, right? It's a tricky one. It's not easy, but if you think of it in terms of decimals and then go back to fractions, it will work. Then we have a real easy step. Just divide both sides by -1, because you don't want to know what a negative G is. You want to know what a full-blooded OG is. And that's 3. That's the original gangster right there. 3.25. All right? A lot going on there. Now, I'm going to pause for a second. Instead of multiplying both sides by 3, what did we learn is an easier way to even tackle this altogether? Multiply both sides by 6. So here's what happens, though, when I multiply this side by 6, I get 7. That's so easy. I'm just going to keep 7 over there. It's wonderful. This does not become as easy. When I multiply this side by 6, I already have 2 groups of this, right? If I multiply this whole thing by 6, how many groups of 5 minus G will I have? If I already have 2 groups of them, and I multiply it by 6, I will have 12 groups. I will have 12 groups of 5 minus g divided by 3, right? That's one way to think of it, which of course, if I have 12 groups divided by 3, I really only have 4 groups of 5 minus g, because I would cross. So that's why when I told you before, if I cross-reduce before I consider how many that is, if I cross-reduce, this becomes a 2, this becomes a 1. I originally had 2 groups of 5 minus g, and I'm going to double that amount by multiplying it by 2. So therefore, I'm going to have 4 groups of 5 minus g. It's kind of complex, but it's really important you understand what it means in order to be able to interpret that way, right? And once we have that, we have 7 equals 20 minus 4g. We would then have negative 13 equals negative 4g. Right now, I'm like, yeah, this is a lot easier because now I have no fractions. It's so much easier. Divide by negative 4, and g will equal 3 and a quarter, positive 3 and a quarter, right? There's no comparison between the two, right? One is so much easier when you don't have to deal with fractions. As long as you understand multiplying both sides by 6 is a beautiful thing, then Bob's your uncle. Okay, question 10. We're on to question 10 now. We only had to do A and D. So, does anybody know what my thinking has to be to make this work? Jada, how do I have to think of that left-hand side? What do I want to think of to make this easier for my next step? I only have, how much of x plus 4.1 do I have? A third of it. So if I think of that as being a third of x plus 4.1, then tripling that, right, will give me a full value of this. That makes sense to everyone? But of course, numerically, we have to triple both sides. I get 7.5. And I've created a fairly easy question right now, right? Subtract 4.1, and x will equal 3.4, right? Easy peasy, lemon squeezy. Now, what makes D different than A? Well, there are two things that are different. The first thing that's different is that you don't have a fifth of 4.6 minus A. You have a negative fifth, which contextually is fairly confusing because it doesn't really make sense to have a negative fifth. A fifth of it makes sense, but a negative fifth, as long as you're procedurally okay, you can work through it. The other thing that's different about this one is that we have our constant term first and our variable term second, where here we had our variable first and our constant second, which is a typical way to express it. So there are a few variations in this one, but procedurally it's identical in terms of how we're going to approach it. So the first thing we're going to do is, I don't want to know what a negative fifth is. I want to know what a full version is. So a full version of this amount is going to be equal to positive 10.5. So by simply multiplying both sides by negative 5, we end up with this simple equation. How many steps is it now? It looks like a one-step equation, but it's really a two-step because we do have to finish that negative 1 coefficient. So we're going to subtract 4.6 from both sides. And we're going to get 6, we're going to 5.9 is equal to negative A. I'm not done yet. I divide both sides by negative 1, and A will equal negative 5.9. Question number 12, it says the mean of two numbers. Oh boy, that's bad. The mean is a fancy mathematical word for the average. And if we think about the average, if we take two numbers and add them together and divide them by 2, you will get the average of those two numbers. So any two numbers added together divided by the number, so that would be the average. If I take x plus y plus z, 3 numbers, and add them together and divide by 3, I would get the average as well. So when we're dealing with two numbers, we would use x plus y divided by 2 equals the average. If we're dealing with 3 numbers, we'd say x plus y plus z divided by 3. If we were 4, we'd say a plus b plus c plus d divided by 4 equals the average, etc., etc. So I'm going to start with this idea, and I'm going to say, well, the average of two numbers is 3.2. So I'm going to swap out average for 3.2 because that's what it tells me. And it says one of the numbers is 8.2, 8.1. So I have a choice. It doesn't really matter. I could make the y 8.1 or the x 8.1. Which one do you think is the easiest to the eye to change for 8.1, the x or the y? The y is easier on the eye to swap out for 8.1. And the reason why it is because we're used to having variable constant in that order, right? So there's our equation. I'm going to solve it by doubling both sides. A full 8x plus 8.1 are the two numbers. Is going to be equal to 6.4. I'm going to subtract 8.1 from both sides. And x is going to be equal to negative 2.3. So the two numbers are x is negative 2.3 and y is 8.1. The average of those two numbers is 3.2. Negative 2.3. Is that right? Oops, I made a mistake. It's negative 1.7. My arithmetic was off on that one, so we're good. All right, your last question from homework says two equilateral triangles differ in sides by 1.05. So right away, I'm going to draw two equilateral triangles. An equilateral triangle is all three sides are the same. And I know that they're not the same length, so I'm going to draw them one bigger than the other. So it doesn't really matter which one's which. Okay? So they differ in sides by 1.05. Now, from experience, I know here's what I'm going to do. I'm going to make the smaller one x, x, and x. Okay? And if the bigger one differs in side by 1.08 meters, then each of those sides is going to be x plus 1.08. And right now, all I've done, I haven't read anything else. All I've done is I've addressed with a picture what I've just highlighted in green. I've made two equilateral triangles that differ in their side lengths by 1.08 meters. Okay. Now, I haven't thought about the question. I haven't read the rest of the question, but I have interpreted that first sentence as a picture that I've drawn for you. And now that that picture is drawn, I'm going to say the perimeter of the larger triangle, which is over yonder, is 9.83. So the perimeter of this one is 9.83 meters. Determine the side length of this one somehow. So if I can create an algebraic equation from this one and solve it for x, I will then be able to tell you what the perimeter of this one is, because I will know the length of x if I solve it in the other one. And that's going to be done. Remember in the first question, I could think of it as x plus 1.08 plus x plus 1.08 plus x plus 1.08. That's one way to get the perimeter, but a more intelligent, mature way to say it is it's three groups of x plus 1.08, or 3 multiplied by x plus 1.08. This is the perimeter. And since that number equals 9.83, this algebraic equation can be used to solve. My apologies, I had 8 instead of 5, but that's how it goes. So then these are all 5s here, and that would be my equation. Good. Okay, so 3 groups of x plus 1.05 equals 9.683, so I'm going to divide both by 3. One group of this, or one side of the equilateral triangle, would then therefore equal 9.83 divided by 3, which is that what it is, really? 3.276 repeating, 3.276 repeating. I'm going to subtract 1.08 from that, right? I should have kept it in the calculator. Hang on, let me just do this again. 9.83 divided by 3 equals, what am I going to take away from that? 1.05. Take away 1.05 equals something screwed up here somewhere. No, that's it? So that's x, correct? X equals that. Is that right? What am I going to do with that number to get the perimeter of the other triangle? Times it by 3, because x, this is x, right? And since there's 3 of them, if I take this number and hope to God it's a terminating decimal, oh, thank heavens, then the answer is the perimeter of the smaller triangle is 6.68. The perimeter of this is 6.68.